supported by the Australian Government Antarctic Science Collaboration Initiative, and the AAPP works to improve our understanding of the role of the Antarctic and Southern Ocean within the global climate system and its implications for marine ecosystems. Now, the Australian Centre for Excellence in Antarctic Science is a collaboration between Australian universities and government agencies and international research institutions supported by the Australian Research Council. The goal of ACES is to help the world community prepare for climate risks emerging from East Antarctica and the Southern Ocean by integrating knowledge of the ocean and the atmosphere, the cryosphere, the ecosystems, and their interplay. So welcome again to this presentation. You're invited to write questions in the chat. That will have a Q&A at the end of the webinar, and I'll work through those questions at that time. You can submit those questions as we go through, or of course at the end as well. Now, because of the size of the audience, we will keep everyone on mute and ask you to stay on mute, and the webinar is being recorded today. So today's webinar is Antarctica and the Southern Ocean, Insights from the 2022 IPCC Working Group 2 report. On February 28th of this year, the IPCC released that report entitled Climate Change 2022, Impacts, Adaptation and Vulnerability. It's the culmination of the review and synthesis of more than 34,000 scientific publications, and that report presented a series of key messages, including those that emanate from research on Antarctica and the Southern Ocean. And today we're going to hear from 4 speakers, all of them who have played a key role as lead author or review author for the IPCC's 6th assessment process known as AR6. And following the webinar, we will distribute an electronic document that summarises some of the key findings and messages of Working Group 2's report from an Antarctic and Southern Ocean perspective. And we're going to provide a link as well to the webinar recording. So it's my pleasure now to introduce our first speaker for today. That's Nathan Bindoff. Nathan is a professor of physical oceanography at the Institute for Marine and Antarctic Studies at the University of Tasmania, and he's project leader of AAPP. Nathan was a coordinating lead author for AR6, including the special report on ocean and cryosphere in a changing climate. And we look forward to hearing from you, Nathan.
Thank you very much, Matt. It's a pleasure to be talking about this Working Group 2 report. I thought I'd just step back a moment and talk briefly, very briefly, about the IPCC. The IPCC, the Intergovernmental Panel on Climate Change, is the primary vehicle that all of the world's nations, through the United Nations Environment Programme and the World Meteorological Organization, come together to work on questions of climate change. And we're in the 6th cycle of the IPCC currently, up here in the right-hand corner. But actually, the IPCC started back in 1988. It was the release of the first assessment report that led to the primary agreement and convention, the United Nations Framework Convention on Climate Change. And then since the release in each of these cycles, there's been key decision points that have been made as we've progressed through time. The most recent cycle includes these 3 reports, and they tackle 3 relatively important questions. The first was actually came out of the Paris Agreement, and that I've gone forward one slide. The first came out of the Paris Agreement. This is the SR 1.5. It was addressing the question of whether 1.5 degrees was feasible. The second was actually addressing the question about climate change over land. There is a competition between food security and actually meeting the 1.5 goal. And the third was really addressing what has happened in the global commons around the oceans and the polar regions. Each of these reports has many, many contributors to them, and the current Working Group 2 report has something like 700 coordinating lead authors and review editors. IPCC is proud of its diversity. It's highly representative. The experts are based on merit, And actually through the cycles, it changes its authorship, but the messages are very much the same. I'm just going to focus on the Working Group 2 report that was released actually on the 28th of Monday, the 28th of February this year. It follows the release of the Working Group 1 report on the physical science last year in 2021. Now, each of these reports are reviewed 3 or 4 times. There were, as Matt said, 34,000 scientific studies. This is an enormous amount of literature around the impacts of climate change, how we might adapt to climate change, and the vulnerability represented by those. And these are probably the 4 key messages that I would take out of that summary for policymakers that is distilled out of more than 1 million words. The first message actually is that given the focus of this report around human communities, ecosystems, the first message, the key message, would be that unchecked climate change is going to amplify the impacts and hazards for those communities. You might be surprised to understand actually there are limits with which we can adapt to in climate change, and those limits are being pressed in a number of areas, and that's another key message. We will cross critical thresholds. And curiously, it's actually possible to make things worse through poor adaptation, and food security and climate change mitigation through is an example of where we might get maladaptation. And then finally, like the earlier report, SR 1.5, to meet these goals, we actually have to mitigate rapidly and also adapt. And our second last speaker will talk to that in particular around Antarctica. Now, this report distills up everything for the globe, but what does it actually mean for Antarctica and the Southern Ocean? And here are the key messages that we've distilled out of the report. The Antarctica is clearly changing. It's losing mass. The ecosystems and sea ice are projected to change. The Southern Ocean has warmed and changed and attributed to humans. And these things together are triggering more extreme weather, and through the melt of Antarctica and the warming of the Southern Ocean, contributing to global sea level rise and storm surges. If you think about it, there are not many people who actually live in Antarctica, but those Antarctic and Southern Ocean ecosystems are actually important. It's the home of krill. Our second speaker will talk to that. And in the case of sea level rise, we're contributing to the 1.3 billion people who live in low-lying regions around the world. And then finally, Australia sits at the edge of the Southern Ocean. It's squeezed between the biggest current in the world and Australia. It's the fastest warming region of the globe, disproportionately so. And so it affects our fisheries and natural systems, natural marine systems, and the human communities that depend on those. And as a consequence, and we've shown up multiple times, there's extreme weather that we contribute to from Antarctica, and some of those links are emerging in the literature. And then one of the challenges in a highly unpopulated part of the world is how do we manage or achieve a climate resilient pathway given the Antarctic Treaty System, and the third speaker will talk to that, and the management of the protected areas around Antarctica. And there's a key message there, which is similar to the others, around the need for rapid, ambitious change, because mitigation of the impacts of climate change depends a lot on the mitigation of human emissions. I'll now hand back to Matt King.
Thank you, Nathan, for that. Now it's my pleasure to introduce our second speaker, Professor Philip Boyd. Philip Boyd is Professor of Marine Geochemistry at IMAS, UTAS, and is the coordinator of the Virtual Institute for Climate Solutions, the Climate Recovery Institute. He's a lead author for the Working Group 2 report chapter on ocean systems and review editor of the cross-chapter paper on polar systems. And I'll pass it over to Philip now. Thank you, Philip.
Thanks, Matt. This morning, I'm going to focus on two of the major threats that have come out of this report, threats for life in Antarctica and the Southern Ocean. The first of these is the increasing number of stressors, both environmental, such as warming, but also ecological, the appearance or invasion of non-Indigenous species. And these are really dialing up the cumulative pressures on life in the region. And as I say, they're a mixture of global stressors such as acidification or warming, but then also regional and local. You can see examples here of, again, fishing pressures in non-Indigenous species. If the increase in cumulative pressures wasn't enough, then overlaid on this, we're now starting to see, in some cases for the first time on the Antarctic continent, extreme events, heat waves. And so again, these two taken together, cumulative pressures overlaid with these very abrupt high magnitude events are causing major challenges for life in the region. They're summarized in this slide here, which will be a feature of the report that will be released at noon. And here we can see, if we look from the subantarctic south, we're seeing extreme air temperatures. We've seen those for a number of years in the subantarctic islands, but as I mentioned, 2019, 2020, we've seen them for the first time in East Antarctica. We're also seeing then a range of these cumulative pressures. We're seeing invasives coming in both at the surface with invasive kelps and their associated passengers and microbiome. We're also seeing seafloor invasives coming in. What that's tending to do then is actually then compress polewards the available habitat for many species. And of course, it's important to note that Antarctica is terminus. There's nowhere else to go for many of these species. So we're seeing habitat compression. We're seeing this, as I say, from the subantarctic, the open Southern Ocean, and particularly down in the sea ice region, where we're seeing less sea ice cover is actually altering ecosystem structure. It's removing habitat for krill. It's also boosting some sea ice algal blooms. So we're seeing a wide range of effects in this region. And of course, the other compounding factor we're seeing here is because of the long-standing geographical isolation, many of these species have very narrow thermal windows of tolerance. This is the thermal performance curve. From the minimum temperature you can subsist to the max. Typically, the shape of these curves, we have an optimum temperature here, but we have this sort of thermal cliff face, and even a change of a degree or so can make a huge difference and present a real challenge for species to subsist under such conditions. And if we place the extreme event then in the wider context of the typical sort of projection plots we see in IPCC reports, typically we'll see, in this case here, global surface temperature, we'll see that will increase depending on which projection scenario we're looking at. A fraction of a degree every decade, such that by the time we get to say 2100, we're looking at a warming of 2 to 3 or possibly 4 degrees. Let's overlay on this here then the recent event in 2019-2020 in East Antarctica, where we saw 9.2 Celsius, so 7 degrees above the mean maximum. And these abrupt changes, these heat waves are really going to be what's challenging, because this immediately in the here and now thrusts us well into the next century. And so really mean change will cause major effects, as we know, but then overlaid with these changes, that adds issues. And again, even in East Antarctica, we're seeing minimum temperatures now above freezing are occurring. And one of the major findings from this report, this was a schematic put together by Beck Harris. And here we can see here, as we move across decades, we start to transition with these extremes where there's enough time to recover between these events. But as the duration increases and their abruptness increases, we then start to transition then already from what we term survivable to extinction extremes. And it's likely this is giving us a glimpse into what will start to happen in Antarctica, because as I mentioned, we're only just in the last couple of years starting to see some of these extreme events actually on the continent itself. But certainly there are many lessons then, and this is something that will have to be tackled probably through adaptation that I think Andrew will speak to next. And because of the very recent onset of these extreme events on the continent, then there's very little documentation on what their effects might be. Certainly, we've seen examples from the Arctic about major changes to terrestrial, marine, and cryosphere ecosystems. So again, as I say, we have no information at present, but there are many examples that we're seeing then from other literature in other regions of the ocean. So the report has many things to teach us about what we might expect in the coming years in Antarctica. If I then look again at the effect of these heat waves, so taking then the typical sort of IPCC changes in the main with a range of different scenarios and warming projections, what we see then is that this thermal cliff face, it's very easy for it to be exceeded. And because these events are very abrupt, this gives very little time to acclimate, never mind to adapt. So again, this is one of the reasons why I've decided to focus on this in this particular presentation. And if we look at a census of some of these events, these are for Antarctic phytoplankton species. We see many of the species have a T-opt, have an optimum temperature between sort of 4 and 6 Celsius. The blue bar here overlay is a typical range of polar temperatures from -1.5, and then over the annual cycle in some regions getting up to 8 Celsius. The yellow addition to the bar then is the projected mean increase of about 1.5 degrees for polar regions. So again, we can see even with the mean, never mind extremes, we're pushing many of these resident species out over this thermal cliff face with very unknown sort of outcomes, and whether we'll see a reshuffling of ecosystems. If we return then to this other issue of cumulative pressures, then if we look in particular in the nearshore region, we're seeing mechanical damage from iceberg scar in the region, tearing up the seabed. We're seeing sea ice melt. In some cases, that's reshuffling the communities because we're getting more sunlight penetrating into the seafloor, changing the communities in unknown ways, reducing the amount of krill habitat, but then also giving us increased productivity from some of these ice edge blooms. In the report, we really grappled about trying to understand the mechanisms behind the drivers of these cumulative pressures, because these things don't act alone. They often act in concert with potential amplification effects. We're still trying to tease that apart, but it's clear then if we just take even one of these stressors, in this case here, the global temperature change here. If we look at these IPCC burning ember diagrams, we see as we move up the temperature scale here from 1.5 to 2 degrees, we're starting to really move up into high and very high risk impacts. One of these, as Nathan mentioned earlier, is the krill fishery, which is hugely important to underpinning many pelagic and also benthic ecosystems and higher trophic levels across Antarctica. And as I also mentioned in the previous slide, then we also have sea ice communities, which again are being reshuffled because of some of these fundamental changes to the cryosphere. So again, we can track very readily and compare how changes in the main are moving us up the element of risk in these burning embers plots. There's only been time in this short presentation to sort of focus on some of the impacts on life in Antarctica and the Southern Ocean, but of course, as Nathan mentioned, there is then this wider impact, these teleconnections between Antarctica and the Southern Ocean to the north, on Australia, and indeed to the Southern and Northern Hemisphere. In particular, some of the issues here focus around sea level that Nathan mentioned, and also ocean surface temperature. These were focused on in detail in Working Group 1, but for continuity and to provide context, we've also featured them heavily in the report that will be released to you shortly. And with that, I'll hand back to Matt King.
Thank you, Philip, for that. Our next speaker is Andrew Constable. He's an associate researcher at the Centre for Marine Socioecology at the University of Tasmania, and a quantitative marine ecologist using science to assist in ecosystem-based management of fisheries, conservation of biodiversity, and human implications of long-term dynamics and change in marine ecosystems. He's also a lead author on the Working Group 2 report chapter, on this time on decision-making options for managing risk, as well as the cross-chapter paper on polar systems. So thank you, Andrew.
Thank you very much, Matt. Hello, everybody. Good morning, good afternoon, good evening. I wish to look at, well, what can we do about managing Antarctica and Southern Oceans to support climate resilient development globally? And also, what are the kinds of things that need to be done globally that will help Antarctica and Southern Ocean systems? Climate resilient development has been emerging in the IPCC framework since AR5 and through the special reports. And what climate resilient development endeavours to do is to integrate actions for adaptation and mitigation that help deliver climate resilience and sustainable development for all. In the end, this report has been much clearer on what we need to do now to be able to ensure a climate resilient development future. What we're seeking to achieve in that is success in well-being, low poverty, ecosystem health, equity and justice, low global warming levels, and low risk. We have a number of choices to make, and we do these in a number of arenas. We have, as we would expect when we're dealing with people and sustainable development, we have a number of community, socio-cultural, and political choices to make. But globally, we also have choices to make about the ecology of systems. We have choices about the research and the acquisition of knowledge, the integration of different knowledge systems, and also the development of technologies. And also we have choices about our economic and financial futures. This plot is a schematic of what we can do in order to enhance climate resilient development. We can seek to move towards a world which is, as I described before, or we can stay on business as usual, exceed 2 degrees, and then have a world that we don't wish to live in. A framing for this is the Sustainable Development Goals, and these are listed on the right. Antarctica and the Southern Ocean doesn't contribute to all of these goals, but they do contribute to a number. Antarctica and the Southern Ocean helps provide food through fisheries. They help provide well-being through the cultural connections and the aesthetic reasons that people enjoy the values of Antarctica. It also has an important role to play in climate and global ecosystems. And this particular image comes from a paper by Eugene Murphy and others, and is one showing the linkages between Antarctica and northern continents through bird migration. We also are aware of that through whale migration, and also some fish migrating short distances. And we also know that the Antarctic region is very important for developing peace on our planet. One of the important conclusions of the report is that there are no realistic options for undertaking adaptations in Antarctica to reduce climate risks from Antarctica. This is because the changes that are occurring in Antarctica, as evidenced by the potential changes in the sea ice in the future, the changes in warming temperatures, and the other changes that Philip has talked about, we know that these changes are occurring faster than the natural systems can adapt naturally. There are no options that we can take that will add value to that. Another important thing to think about in relation to Antarctica is that there's not much activity there, so mitigation options in Antarctica are very small. One of the things that's been thought about is, could the Southern Ocean provide support to carbon sequestration? This is only an idea. It's not been demonstrated practically, but also one of the key points about helping mitigation through carbon sequestration is that there may be flow-on effects through the ecosystem that we need to be cognizant of. And there would need to be a very well-tied management system if that was to be taken forward. The most important thing in Antarctica and Southern Ocean is how can we ensure that the resilience of the system is sustained as the global warming level increases. And as we stabilise the global warming level and then hopefully keep it to 1.5, if we can sustain the systems, then recovery will be possible and the system can be maintained. There is potential, though, for the resilience to be undermined from fisheries, tourism and national programs, and this is identified in the report. We know that the krill population, its range is contracting, and could fisheries interact with the krill-based system and cause it to become unstable and move more to a fish-based system? This is one of the big unknowns that needs to be worked on. But it's important that we investigate and manage the potential for compound risks in order to be able to sustain the resilience of the system. Another point that was important and identified in the report is that protected areas are needed to help resilience of the global ecosystems. And there is some discussion about having about 30 to 50% of the systems being carefully managed such that the resilience can be sustained. And in Antarctica, at present, only 5% of the marine system is currently managed in protected in no-take areas in the region. What I show here in the red line is the latitude at 70 degrees south, which gives you a sense of, with the contraction of the polar systems to further towards the pole, you can see here the potential that the West Antarctica has a number of areas of refuge, and in East Antarctica, the Prince Bay area will be important as a refuge. What we need in Antarctica then is a system of areas which help provide for maintaining resilience in the very sensitive areas, such as around the Antarctic Peninsula and also around East Antarctica, which look like they will be very vulnerable to effects of climate change in the future. So how do we sustain the Antarctic and Southern Ocean ecosystem, and how do we maintain its resilience? Importantly, the Antarctic Treaty System is currently talking about how it might work to retain the system, in particular in the Committee on Environmental Protection. They have adopted a work plan for managing climate impacts. But in CAMLR, the Commission for the Conservation of Antarctic Marine Living Resources, there is no such plan for managing the impacts of climate change and maintaining the resilience. So that is a big challenge. But one of the most important features about the Antarctic system is that it requires mitigation globally to be able to ensure that the system is retained into the future. And as Philip has indicated, there is nowhere for the polar systems to go. So mitigation is an essential outcome for sustaining Antarctic systems. Thank you, Matt.
Thank you, Andrew. And just a reminder while we're going to Greta that you can add some questions to the chat as we go through, or at the end, and we'll come to those straight after Greta's presentation. So our next speaker is Greta Petschel. She's Professor in Marine Ecology at the Institute for Marine and Antarctic Studies at UTAS, and she's the Director of the Centre for Marine Socioecology at UTAS. She has a deep expertise exploring the impacts of climate change on natural systems and developing adaptation options for conservation, fisheries and aquaculture. She's also a lead author for the Working Group 2 report, this time on the chapter on Australasia. So thank you, Greta.
Okay, thanks very much, Matt. I don't think I've got control of this. Okay, I do now. Control of the screen. I wanted to start off with a very quick acknowledgement of country. Like the other speakers today, I'm speaking to you from Nipaluna Lutruwita, where I live and work on Aboriginal land, seas and waterways, and I acknowledge with deep respect the traditional owners of this land, the Muwinina people, past, present and emerging. And I think acknowledgements of country are obviously always important, but particularly so in the context of knowledge over time and thinking about what climate change means for our collective future. I'm not an Antarctic or a Southern Ocean scientist, but we've included this very short summary of key aspects of the Australasian chapter of the Working Group 2 report as it relates to Australia, because of those teleconnections between Australia and Antarctica and the Southern Ocean, in particular connections with the southern part of Australia and a lot of our climatic features. So the Australasian chapter was led by a lead author from Australia and from New Zealand. We had a bunch of lead authors, chapter scientists, review editors, and there's also another 41, I think, contributing authors to this chapter. So it represents a large body of work from a number of people, and I'm just doing the highlights here today. Two of the headline statements from the Australasian chapter were around natural systems, in particular observed impacts. And so the headline statement here is climate trends and extreme events have combined with exposure and vulnerabilities to cause major impacts for many natural systems, with some experiencing or at risk of irreversible change in Australia. And that was with very high confidence, and it included things like looking at coral reef systems, loss of native species from Australia, and then droughts and floods and processes like that. Extreme events such as heat waves, droughts and floods, storms, fires have caused deaths and injuries and affected many households, communities and businesses via impacts on ecosystems, critical infrastructure, essential services, food production, the national economy and valued places and employment. So the report was really strong on the impact of extreme events on our natural systems and our human systems. And if we look at the key regional risks for Australia, those 6 burning embers diagrams that Philip explained earlier on the side there, they all relate to natural systems in one way or another. The system that was indicated to be at greatest risk was coral reefs in Australia, in particular on the Great Barrier Reef. And if you look at where the very, very deep purple starts on that very first burning embers diagram there, that's at 1 degree with a very high confidence. The 4 little stars there means a very high confidence in terms of that transition from high to very high risk there. So the indication is that we are already at very high risk with very high confidence for our coral reef systems in Australia, and at high risk for our kelp systems. And then the other natural systems that are indicated to be at risk, our key risks in Australia relate to loss of alpine biodiversity, forest ecosystem collapse in southern Australia, loss of natural and human systems in low-lying coastal areas, and disruption or decline in agricultural production, in particular in the southern and eastern Australia. So 6 of those 9 key risks for Australia really focused on the impacts of natural systems. And then if we look at the other 3 risks on the side of the slide there, increase in heat-related mortality in Australia, cascading impacts on cities and settlements, and failure of institutions and governance systems to actually manage those climate risks. And I've got an example of that in the next slide. So just very quickly looking at some very not Antarctic seemingly related phenomena, but loosely related because of those teleconnections. Changing flood risk was something that really came out in the report, and unfortunately, many of you listening are probably affected by these events that we're seeing at the moment. So extreme high rainfall will become more intense. There'll be an increase in risk in cities, urban areas and small catchments. The flood response in rural areas will depend on changes to that high extreme rainfall. And that adaptation to the changing flood risk, again, as we're unfortunately seeing, is currently mostly reactive and incremental in response to the floods. So the amount of funding that's invested in proactive adaptation to floods is very, very small compared to the cost that we are now having to pay in terms of responding to these extreme events. Escalating impact and risk of wildfire was another key risk, and that frequency and severity of that dangerous fire weather has increased and will continue to increase. And it's an example of one of those cascading, compounding, aggregate extreme events and the flow-on effects that they all have through many, many different systems. So it's not just an impact on natural systems. There are many escalating impacts of those. If we look at just the 2019-2020 fires, for example, obviously lots of deaths and uninsured losses of buildings, but impacts on tourism, hospitality and agriculture, and smoke-related deaths and losses of forest and many species and extensive loss of habitat, but then also impacts like smoke carrying over to New Zealand and increasing snow and glacier melt there. And obviously these impacts that I've mentioned in terms of floods and fire are on top of, you know, what I'm hoping is obvious, the very human impacts of these kinds of events. And with this fire example, we could have had another 3 or 4 slides of you know, multiple impacts through all sorts of different aspects of the human and natural systems. So these impacts are really becoming quite extensive and compounding and cascading in their nature. If we look at marine systems, coral reefs, the significant loss and degradation of corals, again, with a very high confidence in terms of the risk assessment there. We saw those 3 marine heat waves in 2016, 2017 and 2020. And we know that the recovery of these reef systems following these repeated disturbance events is very, very slow. It takes the fastest growing corals at least 10 years to start to recover from these kinds of events. And then if we look at the capacity of these systems to replenish and to regenerate, unfortunately, dead coral doesn't make babies. And we know that the recruitment of coral is substantially reduced. So the production of new coral coming into the system in 2018, that was reduced to 11% of the long-term average. So that capacity to replenish is somewhat reduced. Also experiencing significant impacts in the southern parts of our marine system. So loss of kelp forests in southern Australia due to warming, marine heat waves and overgrazing by climate-driven range extensions of herbivores, fish and urchins. So less than 10% of the giant kelp in Tasmania was remaining by 2011, and there's further declines since then, largely due to ocean warming. And also impacts on the west side of our country as well, with extreme marine heat waves leading to a 100-kilometre range contraction of kelp forests in Western Australia as well. And if we look across the whole of Australia, there's been loss of kelp species, of kelp habitat, of around 140,000 hectares in the last couple of decades. So significant loss of habitat for a large number of species. There's actually been very major changes in species distributions, largely as a result of extreme climatic events. So around 45% of the coastline has experienced abrupt and extensive mortality of key habitat forming organisms, so corals, kelps, seagrasses, mangroves. And we've also seen new occurrences and prevalence of diseases, toxins and viruses. So it's not just habitat species that we're seeing changes in the distribution of. And if we look at species more broadly, there's been changes, climate-driven changes in the distribution of at least 198 species from 9 phyla around the Australian marine coastline. And actually one of the key statements from the Working Group 2 report as a whole at a global level was that out of the species that have been studied, around 50% of those are undertaking climate-driven changes in distribution. So plants and animals in the northern hemisphere moving north and in the southern hemisphere moving south, but species doing that at very different rates. So having lots of connections broken and new connections forming and lots of flow-on effects for natural and human systems. Looking very quickly at projected risks for marine systems, even temporarily exceeding 1.5 degrees of warming for a decade or two will result in severe and potentially irreversible impacts, particularly in the Great Barrier Reef. Globally, we know that bleaching conditions are projected to occur twice each decade from 2035. and annually after 2044, and that's under a high emissions scenario. That's clearly not enough time for system recovery in between projected bleaching events. And we know that further ecosystem degradation and loss will threaten livelihoods and coastal protection and cultural values, and that an estimated 10,000 jobs and $1 billion in revenue would be lost per year from declines in tourism alone if bleaching persists at those kinds of levels. In terms of adaptation and limits, limiting warming to 1.5 degrees is unfortunately insufficient to prevent more mass bleaching events, but it might reduce the occurrence of them, reduce the occurrence of events equivalent to the 2016 bleaching by about 25%. Reducing anthropogenic pressures is obviously going to help improve natural capacity. However, adaptation of efforts like coral restoration might slow impacts or help in short-term timescales, but it's not going to prevent widespread bleaching. And in terms of kelp adaptation options, minimising other stresses, local restoration, and having transplantation of heat-tolerant phenotypes would be excellent adaptation options to pursue. However, we need to keep in mind that even those restored systems are still at high risk from future heat waves and warming events. And I think that's all that I had. Thank you.
Thanks, Greta. And we'll go to, and all of our speakers, thank you very much. And thank you for keeping to time as well. There's so much more that could have been said. So I'll just run through the questions that are in there, and please, if you're in the audience, please feel free to add questions now to the chat. So one from Robert Glasser, can you say more about the causes of the abrupt extreme heating events? Are they connected to ENSO or other factors? Why are the intervals between them decreasing? Maybe Philip or Nathan could take that.
I can start with that and then maybe hand over to Nathan. I mean, certainly the projected decrease in the intervals between these extremes, we're actually seeing them, as Greta mentioned, the back-to-back warming events in the GBR. But essentially, we're putting more heat, more energy into the system, and so that's going to push them in that direction. There's been a whole raft of work done on looking at what's driving some of these marine heat waves in other ocean basins, and I'll be passing it over to Nathan to comment on.
Thanks, Phil. So actually the major driver of marine heat waves is the underlying trend in sea surface temperature, and then it's modulated. So ENSO will lift the risk of a heat wave in ENSO years and the other modes. But primarily the biggest driver of extremes is the shift in distribution, and the tail of the distribution becomes more intense, longer, and frequently.
Thanks, Nathan and Philip. So Roland Warner asks, Andrew mentioned no realistic options for adaptations in Antarctica to reduce risks emanating from Antarctica. Was there a view about realistic prospects for geoengineering mitigation of Antarctic ice discharge? Andrew, maybe.
There wasn't any discussion in the working group about that, and in fact that's most likely to be addressed in working group 3, which has the responsibility of talking about mitigation options in particular. The working group 2 report was also building on the special report on oceans and cryosphere, and so we have some ideas about adaptation, but the mitigation is largely being left to that time. Nathan might have more.
No, I don't see any more from Nathan or Philip. So we'll go on. Again, I think for you, Andrew, from Alex Sengupta, you talked about moving from 50 to 50% of managed protected marine area around Antarctica. Is there a political will to move toward this?
I wonder, Matt, if I also take the next question as well, which is from Rob Mathen, thinking about Pritz Bay as being a candidate for a long-term monitoring area.
Go for it.
Taking the first question, we've seen since the establishment of the Ross Sea Region MPA, the development of marine protected areas in Camelot has more or less stalled. There are proposals on the table, a long-standing one for East Antarctica, one for the Antarctic Peninsula, and one for the Weddell Sea. One of the things here to consider is how do we move that forward? Rob's suggestion about long-term monitoring is a good thing to ensure that activities are undertaken in such a way that they can inform Camelot, even in the absence of establishing formal protected areas. So there is a good coordinated program on the Antarctic Peninsula. There is a proposal to have such a program in the Weddell Sea. And the Ross Sea has a number of elements of a coordinated program there. Pritz Bay would be an obvious place to start to develop a program because Pritz Bay, Weddell Sea and the Ross Sea are clearly options for climate refugia in the future. And so developing programs there would be good. But the protected areas in the other places, so around the Antarctic Peninsula and around East Antarctica, are very important for developing or maintaining resilience to the effects of climate change over time, and not to introduce compound risks associated with fishing, tourism and national programs. And at present, the Peninsula and East Antarctica are very vulnerable for that to happen. It's one of the key questions here is, will the refugia actually sustain the Antarctic krill-based system? Because Antarctic krill, as you move towards the continent, gives way to crystal krill and the Antarctic silverfish. And so it's not entirely clear that Antarctic krill will end up being dominant in those embayments that might be refugia in the future. And that's a really important area for research. And until such time as that's established, and it's not clear that it will be established, then the dependence on the sea ice system is really important to focus on and identify whether the krill-based system will survive a loss of sea ice. And while we wait for that, then there needs to be very sensitive management in the Antarctic Peninsula and East Antarctica in relation to these sensitive systems, because it's not clear that they will survive with a high fishing pressure.
Thanks, Andrew. So we're going to go to Greta now, and I know Greta's reflected on this broad area. How can we best teach about existing and projected climate change impacts to university first-year students so it's not depressing or frightening?
Yeah, that's an excellent question, because on many levels it is kind of depressing and frightening, and anxiety would be a normal reaction for many people to have in the face of these kinds of considerations. But I think it's important to surround ourselves with like-minded people for a start, and to remember that actions and doing things and being part of the solution rather than part of the problem is something that, you know, makes us all feel better about it. And that ultimately every fraction of a degree of warming that we avoid improves the outcome. That's the thing that I, you know, remind myself on a daily basis, that although we talk about 1.5 and 3 and 2 and, you know, all these values and targets, or limits rather, essentially every fraction of a degree of warming that we avoid is progress, and it improves the outcome. So I just try and encourage other climate scientists to be talking about both of those things, you know, the impacts and the potential risks, but also the possibilities, and how we can help improve the situation. So we know that messages of doom and gloom switch most people off. I find that really difficult because it makes me feel hypocritical talking about, you know, this optimistic potential future when that's not where we're headed at the moment. But I find trying to present both those things and hold them at the same time and just remind people that the future is a choice still, essentially, and that we just need to, work together and try and communicate clearly. And when we're communicating with people that are deniers of climate change, to try not to shame them and make fun of them, however tempting that might be, and to just really try and focus on bringing more people along and communicating in a clear way and highlighting what the possibilities are for the future.
Thanks, Greta. I noticed that Nathan, you came off mute. Did you want to add something?
Yeah, I would just add the rather important fact that actually all of this is projections. It's subject to decision making. And in fact, the whole of the IPCC was created to actually address and confront this issue around climate change and its consequences. And so if you think about it, the fact that we have this discussion going on is a really positive thing in terms of addressing climate change. You could imagine an alternative planet where we didn't even have an IPCC, we didn't actually have a engagement across all the countries that even contemplated the things that we need to get to a preferred outcome, if I can put it that way. So nothing yet is set in stone. We actually have the power to make the decisions to drive in the right direction. And that's actually what these reports are about.
And Nathan and others, that takes us, I think, to Chris McCracken's question about the policy levers individual states and territories might utilise to assist in addressing the concerns today. Nathan, did you want to start off and then others can jump in?
Yeah, so there are a number of policy levers, and policy's not my strength, perhaps, but it's easy to correctly imagine that planning at local government levels includes climate change information. On the mitigation side, policies around how to change and take into account the external factors to do with emissions is another policy. There is policy around setting laws to take into account climate change questions. There are a range of other things. So there are policy instruments if there's the will to use them.
Can I just add here too, Matt, that one of the points that we talked about in chapter 17 on decision making was that, like Greta was saying, there is bottom up as well as top down processes that can be entrained. When particular levels of government look at their business, then they tend to look at, well, what are the risks that they have to confront and how will they deal with those risks? In Antarctica, for example, the risks of climate impacts in Antarctica are increasing, but the Antarctic Treaty System doesn't have the power to change those risks. They have to rely on other institutions to do that, both national governments as well as the UNFCCC. And it's the same as like a local government in Australia or a state government. It's important to understand what the risks are and how they're changing. And when those risks aren't able to be managed well at that level of government, then it's important to be able to say to a higher level of government that what they're doing is impacting on their ability to manage risks, and that the risks may be getting greater and impacting on their business. And I think that's a very important step to be able to take. So to start to push upwards to identify where higher decisions are needed in order to help the lower levels of government manage climate impacts.
Greta, I wonder if you wanted to add anything on this? No? Hey, Philip, nothing?
It's such a broad topic, but I'm very encouraged by what I'm seeing coming out of the states and territories. People like Matt Keane up in New South Wales, some of the approaches down in South Australia, and pushing along, I think, with some of the work on hydrogen again, I think these are promising, and I think states and territories are sort of showing the way in that respect.
Thanks, Philip. We'll go to Rupert Summerson's question. In terms of mitigating risks from human activities in Antarctica, the recent paper by Cordero et al. 2022, Black Carbon Footprint of Human Presence in Antarctica and Nature Communications, demonstrated that human activity is resulting in increased albedo and therefore snow melt. This paper came out after the IPCC report, but would the panel like to comment on the potential value of starting to reduce human activity in Antarctica? Maybe Andrew for that one.
Yes, thank you, Rupert, for the question. The absorption of heat as a result of the blackening of the snow is certainly, snow and ice is certainly an issue that is coming to the fore. And there are means by which that can be managed. That's being demonstrated by some of the activities in the Australian stations where renewable energy is made possible. And certainly that's an activity that what you're suggesting can help. How that then translates through the Antarctic Treaty System is not something that we talked about.
Thanks, Andrew. We're just about running out of time, but I noticed Nisha Harris's question came on the back of Joanna's one about teaching the reality to the broader public and messaging. What can individuals do to help? What does this mean for me? More broadly, Greta.
Yeah. So I think that there's a number of ways that we can engage. Curious Climate and Curious Climate Schools were two recent projects that we had out of the Centre for Marine Socioecology, where the first one, Curious Climate, where we collaborated with ABC Radio, and they put a call out across the Tasmanian public saying, what questions have you got about climate change? And we got 300 questions, and then put teams of scientists together to go and answer those specific questions in different regions around the state. And then the schools version, where we put the call out to schools and got 1,000 school kids asking us questions about climate change. And then we put a team of 58 different experts together to answer via text writing or short videos to answer their questions. And I think that one-on-one and listening to the public and what questions they've got is a big step forward in terms of generating trust and people getting to see who we are and what's important to us, rather than being faceless climate experts that people can't see or get to know. So I think in terms of messaging with the public, those different kinds of more dialogue type approaches are something that's really effective. We've had very positive feedback from people about those kinds of approaches. And then in terms of what people can do at an individual level, so we can either do individual actions, collective actions, or push for systemic change. Reducing our own footprint is obviously a good start, but I think it's important to highlight to people that people have got to start where that we've got to meet people where they are. So, people that are in very lower socioeconomic circumstances, I think we need to be careful around messaging for, pushing for what they should and shouldn't be doing when they have other things to worry about. So meeting people where they are, not being climate zealots. We need lots of people doing lots of things rather than a handful of people doing things perfectly and then giving up if they're not perfect at it. Talking to people about climate change, making these conversations normal. Doing things like participating in citizen science is a practical sort of thing that I like to encourage, because it's getting people out in the natural world and documenting change, and hopefully that's providing more connections to places and in a local way, as well as giving scientists more information about how things are changing. And then encouraging people to ask questions about climate change and pointing them to reliable sources, and hopefully trying to educate people on what is a reliable source of information and what isn't. So just a few things there.
A great few things. Thanks, Greta. That brings our time to a close. I just wanted to thank you all for attending. Keep your eye on your inboxes for a copy of this report later today. Really do feel free to share the report. More than that, just as Greta's been saying, talk about what you've been thinking about and we've been talking about today. Not just with your professional peers, but your neighbours and your friends and family as well. and the recording of the webinar will go out as well. So look, thank you to the panelists, and thank you all for attending. All the best.